Okay, we're going to talk about the triangle sums corollaries. So by triangle sums, all the angles in a triangle have to add to 180 degrees. So measure A plus B plus C has to equal 180. But if it's a right triangle and angle C is 90 degrees, if we take 90 away from 180, we're left with 90 degrees to be the sum of angle A plus angle B. So we could say that A and B are complementary angles. If we look at the next corollary, there can be at most one right or obtuse angle in a triangle. Sort of the same idea works. If you get a 90-degree angle, then the other two angles have to be acute because you have two angles that make up the remaining 90 degrees. So each one has to be acute. If you have an angle that's bigger than 90 degrees, then you actually have less than 90 degrees left to make up the other two angles, because let's say it's 100 degrees. If you do 180, take away 100, you have 80, and so 80 degrees has to be the last two angles. So you can have at most one right or obtuse angle in a triangle. So for if two angles add to 90 degrees, they have to be acute angles, which makes them complementary. And if you have the obtuse angle, then as we do the math on it, 180 take away some angle bigger than 90 leaves two angles that are less than 90. So they have to also be acute. But basically it just means that you can only have one obtuse or one right angle in a triangle. Let's look at the examples now. For number one, we want to find the measure of each numbered angle. First thing to do is look at the right-hand triangle. We've got a right angle and a 30-degree angle given to us in triangle RWS. So 90 and 30 is 120. If we subtract that from 180, we get 60 degrees. So angle 2 must be 60 degrees. The measure of angle 2 must be 60 degrees. Now, if we look at what's going on there at R, they're showing us that 1 and 2 together make a right angle. So if 1 and 2 are complementary and one of them is 60, then angle 1 must be 30. So we can find 30 degrees for angle 1. And that's it for that one. Let's look at number 2. Number 2, looking at the right-hand triangle, we have 66 and 58 plus measure of angle 1 has to equal 180 by triangle sums. So 124 subtracted from 180 is going to give us 56 for the measure of angle 1. Now by vertical angles, angle 2 must also be 56 degrees. So in the right-hand triangle, we have a 56 and a 50, which comes out to 106, and angle 3 must be the difference of 180 and 106, which gives us 74 degrees. So measure of angle 3 is going to be 74 degrees. Okay, let's look at number 3 then. Number 3, you want to find the measure of triangle ABC. We've got an exterior angle, which is 145, and by the exterior angle theorem, an exterior angle is equal to the sum of the two remote or opposite inside angles. So 2x plus 95 must equal 145. If we take 95 away from both sides, we have 2x's is equal to 50, which means that x is equal to 25. But now they want us to find the measure of angle ABC. Angle ABC is 2x, and 2 times 25 gives us 50. So the measure of angle ABC must be 50 degrees. Looking at number 4, we have another exterior angle, 58 degrees, and that's got to be equal to the sum of the angle at E and the angle at F, which are both x. So basically we have 58 is equal to x plus x, or 58 is equal to 2x, and x must be 29. So I'm just showing there the exterior angle theorem using the angle measures. When we plug the numbers in, 58 is equal to x plus x, or 58 is equal to 2x, which means that x must be 29. And they want us to find the measure of angle F. The measure of angle F is 29 degrees. And I think that's all for this side then. So this was the part 2 of the 5-1 notes.